All right, welcome back. Today we're going to go over two different methods, one of which is taking square roots and the other being completing the square. Okay, so we're going to start with this warm up. So we've been working with quadratic equations, and usually they're in the form. So when we have something like this, I usually put in the third term. This is what we practiced when we had our quadratic, and we use factoring. Okay, so when it didn't have this x term, we went ahead and just put 0. So the first thing we do is multiply the leading coefficient with the constant. Okay, and we do the x game, right? So -9 goes on top because that is 1 times -9, and the linear coefficient goes on the bottom. So now I think of two factors. When I multiply them, give me -9, and when I add them, they will add to 0. So I think, okay, what two factors give me this information? So in class, we figured out it was 3 and -3, right? We multiply these two, give us -9, and when we add them, we get a 0. All right, so then we can write it in factored form. Okay, and with the 0 property, we know that x plus 3 is equal to 0, or x minus 3 equals 0. Okay, and then we just solve for x by isolating our variable. Okay, so here our solution is x is equal to 3, or x is equal to -3. Okay, and this was our factoring. So now we're going to look at some different methods because it's not always going to work out so nicely. Okay, so we're going to go over quadratic equations. We're going to go over the square root property, completing the square method, and for our next video, we're going to do the quadratic formula. Okay, so we know how to find solutions by graphing. So our solutions are the x-intercepts, which are the roots. Okay, and then here we know how to do the factoring method already. Practice that. Next, we're going to go over the square root property and completing the square, and this is going to be next. Okay, I might show one example at the end, but for now, we're going to really get into the quadratic formula in the next video. Okay, so why so many methods? Some methods will not work for all equations, and some equations are much easier to solve using a particular method. Okay, so for the square root property, this method is also relatively quick. However, it only works for equations in which the quadratic polynomial is written in the following form, which is x squared is equal to our constant, or x, our quantity x plus c squared is equal to some number, right? So we have to isolate the square, and then we take the square root of both sides. So that's basically our two steps. We isolate the square and take the square root of both sides, and then solve for x, okay? So we're going to go back to the warm-up question, and we're going to solve that using, because this kind of looks like right here. We have an x squared, but we just have to move over our constant, okay? We want it equal to our number. Okay, so here what I'm going to do is add 9 to both sides to isolate my square. Okay, and then here next I just take the square root of both sides. So that means we have x is equal to plus or minus 3. And you could think of it this way. Well, what number squared gives us 9? Well, one solution would be 3, and another solution is also -3, would give us 9. So here that is why we have two solutions, one being 3 and one being -3. Okay. So we're going to try a couple examples. I'm going to start here. Well, here I already noticed, hey, my square is already isolated. Okay, so I can just, let's see, I'll actually use purple. I can take the square root of both sides. Okay, so that means our x is equal to plus or minus 7. So that means x is equal to -7 and x is equal to 7. So those are our solutions or our roots. Next, here we notice our quantity x plus 3 is squared. Okay, so we have our x is squared, but it's just in this quantity, right? It's already isolated, so what I'm going to do is take the square root of both sides. And that means we have x plus 3 is equal to plus or minus 5. Okay, our x is not isolated, so let's get that isolated by subtracting 3 from both sides. That means we have -3 plus or minus 5. So our two solutions, one being x is equal to -3 plus 5, x is equal to -3 minus 5. Okay, then I can just simplify here. So x is equal to 2, and x is equal to -8. All right, so now I'm going to look at example 3. Well, I have an x squared, but I also have this x here, this term that has our linear x. So because it has to be either, remember up in the notes we have either has to be in this form or in this form, this is not going to work here. I can't use the square root property because this equation is not written in the correct form to use this method. Okay. So you can go ahead and pause and give this one a try, or these two examples a try. Okay, so now we're going to go over the completing the square method. Okay, and this method will work to solve all quadratic equations. However, it is going to be messy to solve a quadratic equation by completing the square if x is not equal to 1 and or b is an odd number. Okay, so that might be messy. So you might kind of say, okay, well, I can't use factoring. I can't use the square root method. Completing the square might not be a good idea because a is not equal to 1 and b is an odd number, so that is when we would use the quadratic formula. Okay, so completing the square is a great choice for solving a quadratic equation if a is equal to 1 and b is an even number. Okay, so these are the steps. So you can go ahead and pause this, get your little note card out for reference when you need to use a completing the square method. Okay, first thing is you isolate your constant. You divide the linear coefficient by 2 and square it. This is what I call the magic number. Okay, and then you add the new constant to both sides, write in factored form and simplify, and take the square root to solve for x. Okay, so I'm going to start with this first example here. Okay, so I went ahead and highlighted, okay, our terms here. So the first thing I'm going to do is, well, it says, let's see, isolate the constant. All right, let's do that. So this is our constant, 13. So I'm going to isolate the constant. So let me move that over to the other side. So I'm going to subtract 13 from both sides. So now I have x squared minus 6x equals -13. Okay, and then the next step says to do the magic number. So we divide our linear coefficient by 2 and I square it. Okay, so that is what we call the magic number, or what I like to call the magic number, right? My linear coefficient is -6. I divide it by 2, which gives me -3, and then I square it. So that gives me a +9. So I'm going to add +9 to both sides. Okay. So then I have this. This is now a perfect square trinomial. And this kind of gives me the clue. This is what I call my little cheating how to write it. So this now can be written as x minus 3 squared. So if you actually factor this quadratic here on this side, this is what it's going to give you. Okay, and then it's equal to, and then -13 plus 9 gives me -4. Okay, now this looks familiar. Now this is a squared on one side. So what I'm going to do is I'm going to take the square root of both sides. So now here I have x minus 3 is equal to plus or minus, and then this I can simplify. I'm going to write it like this. Okay, remember the square root of -1 is I, and the square root of 4 is positive or -2. Okay, I still have to isolate my x. So I add 3 to both sides. So here I have x is equal to -3 plus or minus 2i. Okay. So that means x is equal to, oh, this is a positive 3. There we go. 3 plus or sorry, plus 2i. Okay, and my other solution is x is equal to 3 minus 2i. Okay, we can actually work on this problem here. This is an example when a is not equal to 1 and b is not even. We get a lot of stuff we have to do. We have to make our a is equal to 1, and then we do the same thing here. But I notice here, if I were to just multiply my leading coefficient and my constant, I get 6. And my linear term goes here, and this I can actually factor. So this is a little bit easier. This is just -6 and 1, right? Because I multiplied by this 3, I also have to divide it. Simplify, this gives me -2 over 1, and this does not simplify. And remember, we write it as number over x. So if I write it in factored form, this is 3x plus 1. And this one is just x minus 2. So that would have been way easier than having to deal with all this. And then the next thing would be to set each equal to 0 and solve. -1/3. Well, those are the two solutions there. All right, so that is the completing the square method. Okay, and our square root method. So the square root method, remember, it's best to isolate your x squared and then take the square root of both sides. And here it is best to use a square root method when you have a is equal to 1 and b is an even number. That's the best time to use the completing the square method. These are the steps, and this is how we write our solutions. So next we're going to be going over the quadratic formula. Okay, so see you in the next video. Bye.